Whenever engineers try to solve some problems in real life, they need the assistance of mathematics, right? So sometimes they will come to a conclusion through the mathematical derivations or mathematical analysis. So whenever we derive such results, the actual mathematicians, that is those who are working in abstract mathematics, will take that concept into the next level. So that is what is happening to the convolution also. The idea of convolution sum in predicting the output of a system has been taken by the mathematician to the next level, known as the convolution sum formula. So that there is no systems, there is no signals for the mathematicians. They will consider it as functions for any two functions. How to find out the convolved output? How to convolve two discrete time functions? It can be any functions, right? So how can we convolve two discrete time functions and find the results? That is what we are going to see in this video.
Now let us derive the convolution sum equation, which we have derived in the case of a system, a response and input. The output of a system is given by y of n is equal to summation m is equal to minus infinity to plus infinity. M is varying from minus infinity to plus infinity. X of m into h of n minus 1. That means shifted and scaled impulses response are added to get y of n. This is in the case of a system and a signal interaction. System and signal interaction, right? Signal interaction. Now, this is useful for us engineers. But mathematicians have taken this to the next level and they have generalized it. Instead of they don't have any y of n, they don't have any impulse response, they don't talk about any input signal, nothing like that. They will say C of n, the convolved output of any two signal, right? Any two signal. That is what is happening here also. But they will generally say that any two signal x1 of n and x2 of n will be convolved in this way. That is, m varies from minus infinity to plus infinity. X1 of m into x2 of n minus m. X1 of m into x2 of n minus m. Right. So this is a general equation of convolution sum. And this is one of the beautiful result in signals and system and mathematics. It has so many applications in engineering, mathematics and science, right? So this is a generalization. Actually, this is a generalization of what we have discussed and derived in the previous video, right? Instead of x of n and h of n, they have taken x1 of n and x2 of n and they are writing the equation in a general formula. That is what is convolution sum. I hope that is clear.
I hope the idea of convolution sum is clear for you. It has so many applications in science, engineering and mathematics.